Yeah, no, it's fine, but it was just like, well, I want to make sure I have some idea. All right, entire screen, share. So this is our recording. It's officially recording this time. So, and then I'll also check to see if there's comments. So we're learning from experience. Okay.
25. Do you have it open?
Yeah, I have it. Let me open this. All right, going down. Find the horizontal and vertical asymptotes of the curve. All right. So you start. Did you talk about vertical asymptotes in class?
Mm-hmm.
All right. So I missed that.
It's just this goofy part he does in the example I saw.
All right. So this one is y equals x squared minus x over x squared minus 9x plus 8.
Oh, you want the asymptotes?
Yeah, the vertical and horizontal. So if it would be a vertical asymptote, it would be at, you would say like x equals something that's a horizontal one, you'd say it's at y equals something, right?
Mm-hmm. So the vertical asymptote when it's equal to 0, but since these cancel out, then we get this, right?
Good. So
our horizontal asymptote would be that.
Yeah, that's right.
As equal to 8, yeah.
Good.
And for the other one, we need the limit as it goes to infinity, right?
I think so. I wasn't in class when she did vertical. I had to go set up like 200 people's worth of food.
Oh.
So I don't know exactly what she said at the end of class. That's why.
You did a weird example. Like I even Googled it to make sure. I mean, I went on Wolfram to check if they were equivalent, and they were, but I just didn't understand how we did it. So in the example, he gets actually. Oh, this one's a little different. Can we do this one?
Sure.
The one he did?
Sure.
Okay.
Just.
So
what was his?
It's a little messy. Here we go. No, that's not good.
Is it somewhere here?
Yeah, I'm pretty sure it's this one. Yeah.
It's just almost. Oh, you're saying it's reversed because he simplified on top instead of on the bottom.
Right. So we get. This is what we get.
Right.
And then somehow he gets. No, it's me doing it backwards. This is really messy. I think I did it back here. You can pull it up.
All right, sounds good.
Okay, so he had x cubed minus x.
Over anything?
Yeah, he did.
One sec. All right.
X squared minus 6x. then he called this g of x. Then he was like, yeah, I'm gonna divide through, and then he gets this from these.
I'll tell you what I found, just Googling the way they say to do it. So pretty much, you're gonna get a vertical asymptote when the denominator would equal 0.
Well, right, but I still didn't understand it. Well, this is doing the horizontal asymptote. Right.
Which one? The example
This
that
right
you
here.
have?
Well, we know it's going to be 5, but we want the limit, right?
I don't know if you need to take one to get.
The horizontal asymptote.
Did she say that in class?
Well, either way, this doesn't make any sense.
Okay, so this guy's finding the horizontal vertical asymptotes. Okay, so he pulls out the x, and he has x squared minus 1, and then he simplifies it. So he gets x minus 5 equals g of x. And he's saying x cannot equal 1 for, so that's his vertical asymptote, right?
Mhm.
And then to find his horizontal asymptotes, he's saying x squared plus x. So he's simplifying somehow. How do you get this?
That's what I'm saying. I checked on Wolfram, it says they're equivalent.
Let's try to simplify how we got that.
He says he divided through.
So x squared plus x over x minus 5. So that's the same thing as x squared over x minus 5. I don't wonder if that's right. Plus x over x minus 5, and then so you're just trying to figure out how you got there, but once you got there, do you get what he did, or are you still confused after that?
No, I know what he's doing, I just don't know how he did that step.
How we did that step, let's see. Or we could try to find out. And x, so we have x times x plus 1 over x minus 5. So I don't know, this is me playing around. I don't know what he did, but somehow he maybe.
Oh, you know what he did?
What?
Oh, I can't believe I didn't know this. He did long division
Oh,
between those two.
okay.
You see, so he did.
Oh, it's having to choose to what's trying to write. Alright.
Oops, I meant to do that. 6x. So here we're going to want to plus 6. 6x. Yeah, that's definitely what he did. I'll check what I'm doing. 6x.
You could just use the eraser.
This was 6x. Hold on. That's 30. Cancel. This is 30. And then, so this is 6 plus 30 over, I think it's, I think, no, it's got to be the other one.
Yeah, that's what you got.
What are you dividing through, I guess?
He wasn't very specific about it. So then you got that.
That sounds wrong.
G of x approaches positive or negative infinity.
Okay, so I guess we just take over.
Gives no horizontal asymptote.
Alright, so let's try it for this one.
The denominator of g, x minus 5.
So, if you want to go back to the one we were doing.
Okay. So we're going to call this.
So then you want to have it approaching infinity from the right, I guess. The left and see what you get.
Are you gonna finish? Right? No, sure.
Wait, as it's approaching, it's actually approaches negative infinity. It's negative infinity over negative infinity, which is,
So it's positive.
no, so I think it's just one, isn't it?
Is it?
Because it's like, let's say negative 100 billion something over negative 100 billion something. That's just one, isn't it?
I'm not sure, cause honestly I don't know, cause I feel like infinity is like this unbounded thing, but.
But whatever it is, it's divided by itself.
I mean, yeah. I mean, I get what you're saying, but I don't know. Can you check?
So I know that that's the right answer.
It is.
But yeah,
Okay.
one. And then for
Positive infinity
infinity,
is the same thing.
yeah.
So we have a horizontal asymptote at 1.
At what equals 1?
At x is equal to 1.
Try again.
Oh my god, it's y. Y is equal to 1. We have an at.
Good. Alright. Let's see if we can find someone. Oh, this is like reverse. I don't know if you did 26.
I don't know, we took the one. 26. Which one's 26?
Find the formula for the function has the variable asymptote.
Oh, I did that, yeah.
Alright.
Do you want to do the ones with the guidelines?
Sure. Okay. Guidelines of this section. That's a lot of words. Okay.
That's what I said. I was like,
Maybe I'll open it up and we can look at them and then use the other half of the screen. Okay, 1 second. Because that's going to be a lot to read. All right. Guideline for sketching a curve. All right, the following checklist is intended as a guide to sketching a curve y equals f of x by hand. Not every item is relevant to every function. For instance, a given curve might not have an asymptote or process symmetry, but the guidelines provide all the information you need to make a sketch that displays the most important aspects of the function. Domain. It's often useful to start by determining the domain d of f, that is the set of the values for x for which f of x is defined.
you want to read them as we go?
Sure. So let's do domain. Here, I could even do a half and half for the screen. So we could wait, this isn't a notebook, is it? No, it is. Hey, All right, domain. And by the way, in case you're wondering what the function is, it's y equals x over x squared minus 9. So what's the domain of the function?
Negative infinity to negative 3, negative sure.
All right, good. I'm guessing that's infinity at the end.
Uh-huh.
All right, so intercepts. Let me move this over. The y-intercept is f of 0, and this tells us where the curve intersects the y-axis. To find the x-intercept, we set y equals 0 and solve for x. So intercepts.
You can omit this step if the equation is difficult to solve, say. So the
All right, and then what about the y-intercept? Oh, you got it. Okay. Symmetry. If you want to start drawing your graph, you could have your intercept. Leave space on both sides. All right, symmetry. If f of negative x equals f of x for all x and d, that is the equation of the curve is unchanged when x is replaced by negative x, and f is an even function and the curve is symmetric about the y-axis. This means that our work is cut in half. If we know what the curve looks like for x is greater than 0, then we need only reflect this about the y-axis to obtain that. So if you set f of x, or f of negative x, you get the same thing?
no.
Right, because of that x on top. All right, 2. If f of negative x equals negative f of x for all x and d, then f is an odd function. You want to check that?
Well, we just found out it's odd.
Yeah, but now we double check that. All right, 3. If f of x plus p equals f of x for all x and d, where p is a positive constant, then f is called a periodic function, and the smallest such number p is called the period. For instance, y equals sine x is period.
Yeah, I don't think we got that either.
All right, let's keep going. Is that the next section? Yeah. Asymptotes. Horizontal asymptotes. Recall from section 2.6 that if either the limit of x approaches infinity of fx equals L or the limit of x approaches negative infinity of fx equals L, then the line y equals L is a horizontal asymptote of the curve y equals f of x. If it turns out that limit of x approaches infinity of fx equals infinity or negative infinity, we do not have an asymptote to the right, but that is still useful information for sketching the curve. Vertical asymptotes. All right, so do you want to see if you could find some asymptotes?
Sure.
I guess particularly horizontal ones.
Is this right?
Not really sure what you have at the end. So, right, as x approaches infinity from each end, you get 0. And then you want to also do vertical. asymptotes.
Well, that's just both. That's just -3 and 3, right?
Yeah. So I guess if you want to draw like dotted lines on those places on your graph. And you could draw it on zeros, so give it a different color if you want or something. Okay.
Okay, order.
Alright, for rational function, okay. Going on, slant asymptotes. These are discussed at the end of this section. I don't think we have to worry about this one. Intervals of increase or decrease. Oh, that's the bottom. Okay. Use the I/D test, compute f prime of x, and find the intervals in which f prime of x is positive, f is increasing, and the intervals in which f prime of x is negative. If you want to extend the page and make yourself more space in either direction, that's fine.
It's turning out to be a little more work than we bargained for.
I know, but it's like a good review of like everything you've been doing.
I feel like this is like getting fuzzier. Or is that just me?
I don't know, I'll talk to them. It's definitely not clear, but hopefully at least you could see your own writing. And maybe I could see your writing. One sec, I'm just gonna double check the blackboard. Wait, this is, oh, okay, I see what you did.
Can you set it?
Okay. All right, now you want to make your chart.
Can't cancel here? You don't think? No, right? Yeah, no, definitely not.
You'd have x squared minus 9 and x squared minus 9. Oh no, you'd have x squared minus 9 and x squared plus 9, right?
So
you could. No, you could cancel.
No, you can't.
Because you could plot a -1 here. Is that good at you?
But then it'd be plus x squared plus 9.
Isn't like anything like this, like a squared minus b, it's a squared minus b times a squared plus b. Like okay, so if you have x minus b squared, this is just a random thing, equals x minus b times x plus b. Right? Isn't that?
It is. But we have x squared minus 9.
So wouldn't it work the same way?
I don't think so.
I think it might.
Okay. Let me see.
I'm gonna plug it in and see if I'm right.
I'm very suspicious of this.
Alright, so I'm gonna plug it in and see what Wolfram Alpha says. See if you have good reason to be suspicious.
I don't think. Well, it's definitely not x squared plus 9. X squared minus 9. I really can't even see this. Let me show like that. You want it?
No, I don't care. More visible.
It does look fuzzier. You see this eraser?
Yeah. Alright, I'll complain on when I go in next time.
I don't think that's correct.
Yeah. They say it's the same thing as, oh, you know what? That's why. Anyways, it's the same thing as x minus 3 squared times x plus 3 squared.
But you're right, but that'd be if it's x minus 9 squared, not x squared minus 9 squared.
No, I'm saying this turns out to be x minus 3 squared times x plus 3 squared.
When you factor it all out?
Yeah.
Or,
But I don't know if that's helpful, so we can just leave it.
I don't think it is though.
It is. I don't know.
Just show me. I don't know. I don't buy this.
What that? Okay. So, let's say we have x plus 9 squared, right?
Right.
So that's normally what?
You mean x minus 9?
Yeah, sorry. That's the same thing as x plus 3x minus 3, right?
Mm-hmm.
So I didn't write that out like this way. That's, I guess, whatever. So for this, negative, or no, this isn't negative, it's positive, right? X squared minus 9 is the same thing, or squared, is the same thing as x squared minus 3 x squared plus 3. And you don't want to buy it though.
It's not.
Look at Wolfram Alpha.
Because that's x to the 4th minus 9.
What's x is this?
Yeah, this on the
No,
bottom.
if you multiply the whole thing out. Okay, so what you'll get used to in math a lot is that, like, especially when you start doing integration by parts, you substitute variables for other variables because it's just too complicated. So if you substitute u equals x squared, because we're not doing anything to x squared, it's still x squared. So then you would have the same thing as u minus 9 squared, which is the same thing as u minus 3 u, I don't know why it's more like a mu, plus
Yeah, that's what it looks like, right?
Yeah, I don't know. I guess I'm just used to mu's from my math class.
Right, but if you multiply this out, you get x to the 4th minus 9. And those
Are you
are
sure?
those aren't equivalent, yeah.
So let's try it. X, okay, I'm just going to do it this way. X squared minus 3. You want to check on Blackboard for me for a second?
I mean, I see what you're saying. It's that x squared that's.
That's like, it's weird for you because you're like, wait, it shouldn't be that way.
Yeah, no one's on there.
Alright. So, x squared minus 3 times x squared plus 3 is the same thing as x to the 4th minus 9.
Mm-hmm.
Which is the same thing as what's above there, if you want to calculate it out. But the point is that if you see substitution here, but nothing's happening to the x squared, right?
But x to the 4th minus 9 isn't equal to x squared minus 9 squared.
Maybe it is.
Someone's gonna watch this and gonna be like, oh my god, they got into this petty argument for half an hour and I didn't learn anything.
Well, you know what? Then they should come. Okay, so on Wolfram Alpha, if you do x squared minus 9 squared, you get x minus 3. Oh, that's why. Because it's not this. It's this. And how did we get there? Well,
Thank you, Eliza.
I'm sorry.
So, I am hard-headed, and so are you.
You don't believe that, or you do?
I buy that.
Yeah.
Draw. Can I have my marker?
Sure. Here, we could erase our man.
I'm kidding. It's fine.
Okay.
Okay, moving on.
Moving
So
on.
we can't cancel.
So either way, we can cancel, but
Let's see. What do we have?
what's important is to be able to argue your point and know the math to argue it right.
At least right. And this is x squared and stuff. What are we doing? This is our derivative.
Yeah, we're finding the whole table thing.
Okay, so this. So then this is. What are our intervals though?
From negative infinity to -3, from -3 to 3, I think.
Are they?
I'm pretty sure you could double check up here.
No, I mean like, for the derivative, aren't they different or are they the same?
Well, if you factor it out.
But,
Oh, yeah.
but isn't this where a derivative doesn't exist?
Sorry.
But then we run into another problem, because then we do +9 divided by -1, and we get the square root of -9.
Let's just try it and see what happens.
No, like literally +9 divided by -1. Do you see what I'm saying?
And
We're just doing the numerator.
okay.
Talking about that, I watched this really good video you should probably watch. It's about imaginary numbers. It's like an hour and a half long, but you should watch it.
All right, sounds good.
But what do you know to say about this?
Well, okay, so we just need to plug in numbers and see what happens, right? Like plug in from the interval, like plug in -1.
You know, yeah, let's just do, well, I mean, since it's not defined at those points, then let's just do 2, -3, and 0, 2, 3. Let's try this.
So, like, I guess plug in -4 for the first one or something like that.
Mm-hmm.
Gonna do separate intervals so you don't have to do it all in your head.
Yeah.
You're gonna need 2, right? 2 more intervals. One for the top, one for the bottom, one for
Do we?
F prime. Well, because you want to find is a positive or negative on top, is positive or negative on bottom, and then what?
Oh, that's what you meant. Okay.
Yeah.
Okay. -4. This is negative. This is negative. This is positive. Right?
Wait. Yeah, negative. That one's positive.
And this one's a positive for both of these. This is positive for both of those. And what are we doing with these?
So we just needed to find if it was increasing and decreasing. That was, I think, for E. Compute f prime of x and find the intervals on which f prime of x is positive is increasing and the intervals in which f prime of x is negative, f is decreasing. Okay, local minimum and maximum values. Find the critical numbers of f, the numbers where c. The number c where f prime of c equals 0 and f prime of c does not exist. Then use the first derivative test.
I think we do that instead, to be honest. So we have a minimum at -3. So it doesn't exist at. Oh yeah, we already know this. So it doesn't exist. Something negative. And
We do find any local maxes or mins.
yeah, we -3 is a local minimum. Is that right though? Because it's not defined at -3.
Yeah, that seems, well, I guess it's an asymptote, so
So it's not.
it's not really.
That doesn't make any sense. I feel like we did this wrong. I feel like we took or I took the derivative wrong.
I think the derivative was fine. Let's double check it. But
Did you put it in Wolfram Alpha or no?
no, I could do that. All right, what was the original one?
X over x squared minus 9.
Okay. Derivative x over squared. And you got negative x squared plus 9 over x squared minus 9.
Plus 9?
Oh, it's the same thing. It's just that they pulled out the negative. You got the same thing as them. That's fine.
Maybe there are no local maximum.
It could be.
It could be. Wait, what are our options for the graphs? Or you can't show me?
Oh, I guess I could show you. Yeah. There are these two. And these two.
So if there's gonna be no max or min, it's gotta be. It's gotta be
this one or
either
that
that
one.
one or that one. Yeah.
All right. So we've narrowed down our choices.
And we know it's decreasing from. No, this is. I think this says it's increasing from -3 to 3. Oh yeah.
Well, let's look at them. Okay, and this one is the slope increasing from -3 to 3. What about in this one?
No.
Well, from -3
That'd be the
to
full.
0, this slope is increasing, right? It's going from being negative to being 0.
Right, but we took the interval from -3 to 3. Let's
You
do
can
kind
take
of.
it from 0
You want to
to
take this?
-3 to 0 and then 0 to 3.
Oh, we did get 0. I left that out. It's up here. Where is it?
I think you left out an interval if you go up. You went from negative infinity to -3, and then you went from 0 to 3, but you skipped from -3 to 0.
Is that a 0 though? Or is it just a really bad 3?
I don't know. But 0 could be one of the things, because if you just have x on top equaling 0, and that could be one of the points, right?
I thought I wrote it down. Whatever.
By the way, if you want to send me what problems you want to do in class before, then I can look at them before, so I'll know more what I'm talking about.
Yeah, I'll send you an email when I finish this. I'll probably finish it today, so I'll probably start the next one.
Because I usually like skim over it, but I don't know like what you're gonna have questions on.
I assume you're paying attention in class.
Yes. But still.
What do you do in class? Just homework?
I take notes in general on what you guys are doing, and I do homework, yeah. But I do have a whole notebook of notes from your guys' class, see?
Oh.
So I actually do listen.
Wait, who gave you? Where'd you get those?
I typed it myself.
Oh, those are yours? Oh, that's with no.
Yeah. This is my notes that I take when I'm sitting down in your class.
I need to get that.
It's free. It's really nice, actually. We got like unlimited notebooks and pages and chapters. That's what I use for this and for CS. And I use it for education. Yes. Just on your computer.
Oh, so it's an online thing?
No, it's like you download it. It's like Word, but it's free.
I have Office, but I don't have that. Whatever. So increasing from -3 to 0, and decreasing from 0 to 3.
All right, now I think you might be in a better position to figure out. All right, first one. Does it agree with that?
We're increasing. So it's not this one.
All right, and then these.
Oh, I already wrote these out, right?
Yeah.
So it's gonna be
Awesome.
this one.
Yay. Let's try not to show the group.
You want to do another one?
Sure.
These super long problems.
Yeah. All right. This one is y equals x squared over x squared plus 27. And again, use the guidelines to sketch the curve.
The last 6 are just using the guideline. Okay, so we know our domain is not going to include. Right. So since this bottom part is equal to the square root of -27, does that mean there aren't? No.
Well, the square root of -27, does it exist?
Well, no. So
Okay.
does that mean it's in all real numbers? Okay, sure. And our intercepts.
This will actually be pretty helpful given your choices. It should narrow it down to like about half. All right, so now looking at your choices already, how many choices do you have left?
Okay, we only got these 2.
Yeah.
What's the difference? Oh, one's a lot bigger.
Yeah, one goes up to, has an asymptote at, what is it, 27? And one has an asymptote at 1.0.
So they're both symmetric, right? We can skip this.
Yeah, I mean, they give us that they're all symmetric, so going down to asymptotes. And also they all only have horizontal asymptotes, so.
Okay, so we're only doing horizontal asymptotes. So we have a horizontal asymptote at 1. So I'm guessing it's a smaller one.
Yeah.
Okay.
All right. That one was much faster. Okay.
I think we draw more assumptions from the graph then.
I agree. It'll go much faster. All right. Use the guidelines of the second to sketch the curve. This one's like 31. Okay. Y equals x over x cubed minus 8. And I guess we could go back up. Tar. Go. Tar domain.
This 2? Yeah. Right?
Why don't you divide up the whole?
You want me to?
Yeah.
Is it not 2?
It might be 2, but
It's definitely not 2. Is it 2? It is 2.
okay. But I wanted you to make sure about it. Because if I say wow, then you're like, oh, I don't know if it's 2. Okay. So already you can narrow down your choices a bit, maybe. Oh no, they all have an S. No, they don't. All right, look at your choices.
This is our. So we only have 3.
So now we have 3 choices. Yeah, so it makes our life a little bit easier.
Okay.
Okay. The next one is intercepts. Again, this might almost solve the problem, even without dealing with the asymptotes.
X equals 0, y is equal to 0.
All right, so looking at our graphs, I might be able to solve the problem.
I don't know. We still have. Oh, it's this one, right?
You want to find officially, I guess.
The vertical asymptote?
Yeah. But yeah, it's kind of fun with process of elimination, only 4 graphs to choose from. You don't even have to necessarily do so much.
The vertical asymptotes. Wait, what? We already found it. It's 2, right?
Yeah.
And there's no horizontal asymptotes? Should we go through the process?
Sure.
Okay, so there doesn't exist.
All right, next one. So this one is y equals x times the square root of 5 minus x squared.
Say that again? X minus 5?
A bit different. It's 5 minus x squared in the square root. So it's y equals x, just plain x, times the square root of 5 minus x squared. And so again, the domain.
Gonna be.
Is there any times where x can't exist?
Is it root 5?
Well, the square root of 5 minus x squared has to be greater than or equal to 0, right?
Mm-hmm.
So why don't you solve for that?
Wait, what do you mean?
Solve for x, where x can't be. Or x, what x has to be.
I'm just gonna skip a couple steps. Okay.
Wait, is that the domain?
No.
Go back up a bit, because we're saying that this has to be greater than or equal to 0, right?
Mhm.
So make this a greater than or equal to sign and then solve the rest.
Right here?
Yeah, because it has to be greater than or equal to 0, right? I'm following what you did because you swapped it. So you have x squared has to be less than or equal to 5, and then square root, yeah, x has to be less than or equal to the square root of 5. And that makes sense, right? Because if you would square it,
Then it'd be bigger than 5. Right. Like the suspects. So we got less than or equal to 5. What about the negative one? No,
that's a
right?
good point. You might want to include
Well, I mean, it's already in there, right?
what? No, when you take the square root, it could be the other one.
I guess we'll see.
I can show you the graphs. They're similar. So it's
Okay, so
going
it's gonna
from.
be this one or this one. So our domain is what? So it's not from negative infinity to.
Well, x has to be less than or equal to the square root of 5, or probably greater than or equal to negative the square root of 5.
Well, yeah, but how do we find it?
Oh. So you need to say 5. What does this say? X is less than or equal to.
Plus minus root 5.
Yeah. Well, it doesn't. It has to be greater than or equal to negative square root of 5 and less than or equal to the square root of 5. Because I think what's going on is that so you have the square root of 5 minus x squared has to be greater than or equal to 0. So when you square it though, this you need to do positive this has to be greater than or equal to 0, and negative of 5 minus x
Oh, right.
squared has to be less than or equal to 0.
That's what I was thinking, but I didn't know where it went.
And then you solve for
Are you going to that talk later?
which one?
Some mathematician is going to talk about randomness.
That's cool. I don't know what time is it at.
It's a 6.
Yeah, I have class. I think I
You have
remember
class
seeing
at
it.
6? That sucks.
Yeah, I mean it ends at 6:15, so at least it's almost over. But it's so it's not bad. It's better than sitting at a math class at 6 at night.
I don't mind math.
I like my math class at 4:30. It's a good time. And then you also have, is that what you get for both of them?
No, it's just one of them. So then this is this. I think you get the same thing.
But you get greater than or equal to. No, you get the same.
Yeah.
So maybe it's
Are you
like a
sure?
square root.
Huh?
So maybe it's something with when you put the square root.
Yeah, that's what I was thinking.
So maybe it's something with the square root. That when you square root it, then you do that it also has to be greater than or equal to the other one.
Yeah, do you want one?
No, I'm thinking we had something.
Oh, I thought you knew when you were hinting at it.
No, I'm thinking that maybe when you do the square root here,
You have to take the positive or the negative.
that's what I'm thinking. It could be.
Well, we already did it up.
Well, because, I mean, just looking at it, if it makes sense. If you had, what is it? Like,
Well, let me just make sure. Let me just check. The good old Wolfram. Let me just plot this. Okay, there we go. Oh, never mind.
but isn't that what we did?
No, it's. I don't know. I'm just gonna do what I wanted to do. Yeah, no.
So it did it on the number line. It had the negative and positive region.
No, it just goes. I thought it was that, but it just goes to the negative part. Maybe we copied down the problem wrong.
No, I think it's right. But either way, because of the graphs, we know that.
Okay, so we know it's gonna be greater than equal to 5 at least.
Oh, wait, negative root, greater than or equal to negative root 5 and less than or equal to root 5.
Oh, equal to negative. Okay.
So pretty much we have these pictures to choose from. And then we could do one of those big tables quickly, I guess. Of
Very
F prime.
quickly.
Yeah. To figure it out. I mean, you can.
You have to find F prime. No.
If you test one region, you could figure out the right answer. Because this is.
Well, we still have to get the derivative.
Right, we have to do that.
Do you just want to continue this Thursday if I don't
Sure.
finish it by now?
Sure.
I'll email you if anything.
Okay.
I mean, I think I know how to do it regardless.
Yeah, it's just pretty much find it. The derivative of that. Find like the first maybe 2 intervals to make sure you did it right.
And we didn't have breakfast. Not breakfast. Yeah, I didn't have breakfast either. I haven't eaten since like yesterday.
That's crazy. Eat, please.
I know, that's why I'm going to go to lunch.
Go to lunch, go to dinner.
Oh,
All right.
you're right.